Hey guys, here's a real short video on how to solve equations that have a square root symbol in them. So let's start with something easy. The square root of x equals 10. Everything in math has its opposite. Addition has its opposite in subtraction. And the plus 2 and the minus 2 cancel out, giving us x is 10. Division has its opposite in multiplication. And those guys will cancel each other out. And for the same type of reason, square roots and squares are inverses of each other, and so they will cancel each other out, and that gives you x is equal to 100. Now, it's always a good idea to go back into your original equation and see if it works. And we're going to plug this 100 back in, and we're going to say the square root of 100 equals 10, and so it satisfies the equation. So let's do something with a little bit more to it. What if you do this? So can I go ahead and add, let's equals 11. Can I go ahead and add 1 to both sides? And the answer to that is no. You cannot do that. You have to undo it in the order, the reverse order of what happened. So let's just think about this. When you wake up in the morning and you put your socks on first. Then after you put your socks on, you can put your shoes on. So if you were to reverse this, you'd have to take off your shoes and then your socks to have your nice little feet. So for the same reason, you have to think, what's the first thing that happened to x? And sometimes it's helpful to plug in a number. Like if I plug in a 10, then obviously the first thing that happened to this is not that we took the square root of it, you had to subtract first. So let's go back and look at this. Let's do the last thing that happened to it, undo the last thing. The last thing that happened was it got squared. So we're going to square both sides. X minus 1 equals 100, and then we're going to add 1, and you get 101. Now plug that back into the original equation and see what happens. 101, take away 1 is 100, square root of 100 is 10, and it works. Okay, let's do something like this. What if it's a square root of x minus 1? Well, in this case, the first thing that happened is it got square rooted, and then we subtracted 1. So let's undo the last thing that happened to it. Square root of x equals 11. We're going to square both sides. X is equal to 121. Now you plug it in here. Square root of 121 is 11. 11 minus 1 is 10, and it all works. Now, one thing you have to watch out for, which is kind of frustrating, is something called extraneous solutions. Now, extraneous solutions are where you do everything right, and yet for some reason it gives you the wrong answer. Okay, example. The square root of x equals negative 4. All right, looks like a normal fine equation. Let's just do the same thing. We're going to square both sides. And square and square root cancels out. X is equal to 16. So that seems fine. The problem is when you go back to the original equation and you substitute your answer into it, you get that 16, and you go ahead and place it right here. The square root of 16 does not, in fact, equal negative 4. And the reason for this is we were given something that actually wasn't true. The square root of x will never be negative 4. Why? Well, because when we graph it like this, the square root of x will never, ever get down into the negatives. This is the square root of 1, the square root of 2, and the higher the number, the more positive. The square root could get down to 0, but a square root function will never give you a negative. So you have to test it and see if it works. Sometimes you might have no solutions. Let me give you a really complicated example, but I think it's a good one, of an extraneous solution. So for this one, we want to get rid of this square root symbol. So to get rid of a square root symbol, we have to square both sides. So we're going to square this, we're going to square this. Now, the square root and the square root symbol cancel out, leaving us this. Now, this one is a bit of a chore. We've got to multiply that out. 2x minus 1, 2x minus 1. If you multiply that out, you're going to get 4x squared minus 4x plus 1. Okay, I'm going to do a little sidebar here. Just in case, if you're following along, you're like, wait a second, where did he get that? Let's look at this. 2x times 2x is 4x squared. Underneath, we have a minus 2x with the inner loopy. The outer loopy is a minus 2x. That gives you a minus 4x. And then finally, the -1 and -1 give you a +1. So that's where I got that. Now, whenever you have an x squared and an x in the same equation, you got to make it equal to 0. So we're going to do this, and that's going to give us the nice 0 that we need to solve this. So now, let's go ahead and factor this. Man, these ones are not super easy to factor, but you know what? We're just going to go ahead and give something a try. Let's do 1 and 7. I'm not worried about the signs right now. I'm just going to see, can I get that middle term to be -3 with my combination of letters? And I have a 1x, I've got a 28x, and there's no way I can subtract or add or combine those to give you a -3. So I struck out with 1 and 7, but I'm not discouraged yet. I'm going to try 7 and 1. That gives me 7x, that gives me 4x, and I say, hey, I can do something with 7 and 4 to get -3. All I got to do is make this guy negative, this guy positive. So to do that, that negative, that positive. So we've got that factored. So we have solved the equation. Let me go back. We've solved the equation 4x squared minus 3x minus 7. Well, we haven't really solved it. We factored it, which is pretty close to having it solved. We had 4x minus 7, x plus 1. And we're using that, and this is really comes from our original question. Our original question is 2x minus 1 equals the square root of 8 minus x. Okay, so this is what we have to check in the end, but for now, let's keep on solving this quadratic. So in order for this thing to equal 0, either that thing has to be 0 or that thing has to be 0. So we're trying to think of a value of x that can make this thing 0. Now for this one, it's easy to see that if x is -1, then the -1, if it was placed back in there, -1 plus 1 is 0. So -1, it's easy to see that that's a loose solution. All right, so x equals -1. What about this? Now, for this whole thing to be 0, what would x have to be for that set of parentheses to be 0? We just got to solve this. Let's add 7 to both sides. 4x equals 7. Let's divide both sides by 4. And we get x equals 7/4. Now, it could be that both of those solutions work, or it could be that one is extraneous. You just got to plug them in and see what happens. Let's plug this one in because it seems the nicest. It seems like it should work, so let's test it out. So 2 times -1 minus 1 equals the square root of 8 minus -1. So that's going to be -2 minus 1. Over here we've got 8 plus 1. That's going to be -3. That's going to be 9. And we end up with this impossible statement, -3 is equal to 3. And that's a little frustrating, but it means that this solution that we worked so hard for, we can rule it out. This is extraneous. Okay, now we should, just for fun, check 7/4. So let's plug it in. And fractions are always a bit of a pain, but we can do it. We can plug this in. So let's plug this in. So 2 parentheses 7/4 minus 1 equals 8 minus 7/4. So that's going to be 14/4 minus 1 is equal to 8 is 32/4. And that's going to be 14/4 minus 4/4 equals 32 minus 7 is 25. Now 14/4 minus 4, that's going to give us 10/4. The square root of 25/4 is 5/2, and this is in fact true. 10/4 does equal 5/2. So 7/4, the unlikely weird fractional thing, was our only true solution, and -1 was the imposter. Hope you're having a great day, guys. It's Halloween here, so if you're out trick-or-treating, stay safe and have fun.